So in the last class, we started a discussion on bond valuation, which is a very important aspect of strategic financial management examination. I have quite a number of questions I've marked out from the ICAM Pathfinder. I just decided to forward one to the group. So in the course of our discussion, I will refer you back to those questions to see how what we have learned and what we'll be learning is applicable to all those questions. So in the last class, we defined bond as a contractual agreement between the issuer and the bondholders. And we said bond is one of the sources of long-term financing need of an organization. And there are redeemable and irredeemable bond. And we said redeemable bond is the one in which the issuer will pay both the annual interest and what? And the principal on the maturity date. Whereas for irredeemable bond, the issuer will only make the annual interest payment, but the principal will not be paid. If you look at the notes I forwarded to the platform, I put some characteristics of bond in that note, and which include issuer, maturity, par value, coupon rate and frequency, currency denomination, credit rating, and so on. In the last class, we also talked about yield. Yield is return. That is R in the formula we'll be looking at today. Yield, we said, is the rate of return expected by bondholders from their investments. And we said it is the rate of return received from investing in the bond. We said we have two types of yield. We have the current yield and we have yield to maturity. The current yield, we said we have the formula to be coupon divided by market price multiplied by 100 over 1. And for you to get coupon, coupon is the interest rate multiplied by what? The face value of the bond. The face value is otherwise referred to as the par value or nominal value. And we look at one example in relation to current yield. We also talk about the yield to maturity. We said the yield to maturity is also known as gross redemption yield or internal rate of return. So the yield to maturity is the market interest rate required on a bond. That is, it is the average required rate of return on a bond. That is, the cost of redeemable bond is calculated using what? The internal rate of return or yield to maturity of the cash flows of the bond. Before we go ahead with our discussion tonight, I have a question in relation to what we've treated in the last class. I will just give an highlight of it. Then I will expect you to solve this after the class and forward your solution to the platform. So the question is that Nkechi Limited has 3-year 5% coupon corporate bond with 100 naira face value, and redemption at par has the following spread above the treasury spot rate given below. So now, looking at this question, we have years 1, 2, 3. We have spread. We explain what spread is during our discussion in the course of adjusted present value. Now, this spread is on basis points. BPS is what? Basis point. And we said when you have 29 as your basis point, what is the meaning of 29 as basis point? If you recall, when you have 29 as basis points, 29 will be what? 29 will be what? In that class during adjusted present value, I recall I said when you have 1 as basis points, is the same thing as what? 0.01. So now, when you have 29 as basis point, what will be the interpretation?
0.29.
0.29.
0.29. 0.29. Fine. 0.29%. So now, looking at this question, I'm bringing up this kind of question because I know when some people see BPS, spread, yield coverage, all these things, they'll say, what is this again? I don't want you to say, what is this again? It's what you can know, and it's what you will know by the grace of God. So now, the question is saying that what is the value of the bond based on corporate spot rate? Based on corporate spot rate. When we talk about spot rate, it is the value of bond now, not tomorrow. On the spot, what is the value of the bond? So the spot rate is the interest rate applicable to an investment or borrowing from today until a specific future date. So in bond valuation, a spot rate is also called a zero coupon rate or zero rate. So the spot rate is the rate of return that is currently available for a cash flow occurring at a particular future maturity date. So now, with this question, that what is the value of the bond based on corporate spot rate? Estimate the bond's yield to maturity. Now, the value of the bond based on corporate spot rate will be what? Will be what? This bond, is it redeemable or irredeemable? Looking at the question, is it a redeemable bond or irredeemable?
It's a redeemable bond.
Redeemable.
Redeemable. So since it is redeemable, the question is asking you to calculate the value of the bond. Now, when you are calculating value of the bond, that is the market value, the price. What are the steps we looked at in the last class? What are the steps? Yes? Somebody should say something.
So calculating the value of the bond, we have to use IRR. Can you hear me, sir?
Very well, I can hear you. I can hear you.
Okay, the value of the bond is the price. We are looking for the price.
Yes, ma'am.
Okay, we don't need to do IRR.
Very good.
Yes, sir.
You don't need IRR.
Yes, sir.
Yes. It is when you want to get the cost. It is when you want to get the yield to maturity, the cost of the bond. That is when the concept of IRR will come. But in this case now, you want to get the value, not the cost, the value. So the value, which is the price of the bond, the price of the bond. If you want to get that, you only look at the future cash flows. And what are the future cash flows? What are the future cash flows in this question? The future cash flows will be what?
Coupon payment and the redemption value.
Yes, the coupon payment and the redemption value. From this question, your coupon payment will be what?
5 naira.
5 naira. That is 5% of the face value. 5% of 100 will be 5 naira. And the redemption value will be what?
100.
100. Yes, 100. Now, for you to discount, what are you going to do? For you to discount, what are you going to do? The question is saying that that the redemption at par has the following spread above the treasury spot rate given below. Have the spread above this above the treasury spot rates given below. Now, for us to solve this question, the discounting factor will be what? Each year have their discounting value, and the discounting value for each year will be what?
For year one, 4.17%.
Yes.
That's
For
the
year
trend
one,
yes,
yes. For year
because
one,
this trend is always on a divided by 100. It's on a, what's what they are calling it?
The
this
Um,
is
spread or the basis points.
this is
yeah, it's on the basis points. Yes.
Divide it by 100 and add it to the yield curve rate.
yes. So it will be this yield curve rate of 3.88. When you convert 29 to percentage, it will give you what? In decimal right now. When you convert it,
0.2.
0.29.
so 0.29 plus 3.88% will give you what?
4.17.
4.17. So when you are discounting, when you want to discount to get the market value of the bond, you discount by saying that what? 3.88 plus 0.29%. And that will give you what? That will give you 4.17%. So by the time you want to discount, it will be what? 4.17% in decimal is what?
That's 0
Zero
point
point zero
zero
four one seven.
seven.
Very good. 0.0417. So when you want to discount, you recall your formula 1 plus r to the power of what? Minus n. 1 plus r to the power of minus n. So in this case, for you to discount, because you have the discount value for each year, so it will be for year one, your discount value will be what? 1 plus 0.0417 to the power of what? Minus 1. To the power of minus 1. Let me just solve it so that we will not get confused, because I actually want you to solve it and forward to the group so that we can face other things. Though I know some people are already acquainted with this solution, they know what to do already. But in order to carry others along, let's just show it, show it so that we achieve the purpose of the class. So I'll just solve the A part, then you solve the B part later. The B part involves IRR, so you should be able to do that. But just to give us a clue to what we are to do. So for year one, solution, to get our discount factor for year one, your yield to maturity is equal to yield curve rate plus what? Plus the risk spread or credit risk spread. Yes, which is this? The yield curve rate plus this spread is your yield to maturity, which is what you use to discount for each of the year, because you are giving the values for each of the year. So for year one, it will be what? Equal to 3.88% plus what? Plus 0.29%. And this will give what? 4.17%. And for year two, it will be what? Equal to what? 4.96% plus what? Year 2, 0.41%. And this will give us what? 5.37%. For year 3, it will be what? Equal to what? 5.80. Please confirm what I'm doing. 0.55%. This will be equal to what? 6.35%. Equal to 6.35%. So to get the value of the bond based on the corporate spot curve, what are we going to do? It will be in this form. We'll come up with our table. If you like, you can use your formula. There are different approach to solving it. So I can come up with my table. So we have it, the year. We have what? Details. And we have what? The cash flow, the discount factor, and what? We have our present value. For year 1, determining the value of the bond, your cash flow in year 1, which is the coupon, is what? Is what? That is the interest. And for you to get the interest, let's show it, coupon. For you to get your coupon, which is otherwise known as interest, it will be what? From the question, 5% of the face value will give you what? 5%
5 naira.
of 100 naira will give you 5 naira. Give you 5 naira. So the coupon is a cash flow for year 1 is 5 naira. Now, in this case, do you know why it will not be good for you to use annuity? Because you have what? Different discounting values, different values you will use to discount. So for year 1, your discount value will be what? Will be 1 plus what? 4.17% is what? 0.0417 to the power of minus 1. When you solve this, this will give you what? This will give you what? Equal to what? Are you there?
0.959.
0.
Let's say 0.5, 0.960. That's approximate.
0.959. Let's go with okay, 960, right? You said approximating.
Yes.
For year 2, we have it as what? Still coupon. The value is 5. Your discount factor will be what? 1 plus 0.537 to the power of minus 2. And this will give us what?
0.90. 0.900. 0.900. Yeah.
0.901.
Okay. So this will equal to 0.901. Then for the 3rd year, what will happen? You can decide to split it or solve it together with your redemption value, whichever approach you want. But there is no time. We'll add it. That is redemption value plus coupon. Redemption plus coupon. Whichever approach is, you still get the same result. Either you use coupon for year 3, then you come down again and put year 3 redemption value. But now let's add it. 100 plus 5. This will give you what? 105. So your discounting value will be what? 1 plus what? 0.0635 to the power of minus 3. This will give you what?
0.83831.
0.831. So this will be equal to 0.831. So your PV will be what? Your discount value multiplied by your cash flow. For year 1 to be what? For year 1,
4.8.
for year 1, we have it as 4.8. For year 2, we have it as what?
4.51.
We have it as 4.51. 4.51. And for year 3, to be what?
It's 7.26.
7.26. So the market value of the bond will now be what? Market value of the bond,
96.5.
96.57.
6.57.
96.57. So this is the question. Now, when you see question on bond valuation, don't allow it to scare you. It they will always come, but it's what you can solve. So, and that is why we are bringing up all this so that we get used to it, and be fine when we see them in the exams. So the subject matter, this is just a recap of what we've solved in the last class, but with some little addition or twist. So you can solve for the bond yield to maturity. And solving for bond yield to maturity is coming up with the concept of IRR, where you assume 2 discount factor and you apply your results in the IRR formula. So you can solve that later. Now, for tonight, the subject matter will be on bond valuation using yield curve. Bond valuation using yield curve. Now, you can be asked to determine the value, bond value, that is, to calculate the price at which the bond should be issued. So, in doing this, there are 2 concepts that you can be tested on. You can be tested on spot rates or on forward rates. Now, most literatures did not put forth the concept of forward rate as much. They appreciate the concept of spot rate more. But if you look at the question I forwarded to the group, there was a twist. They applied the concept of forward rate in that question. And as we discussed the spot rates, I'll also show us how to treat the issue of forward rates. All are very simple. There is no any stress in solving them. Now, we talk about the bond valuation using yield curve. The spot yield curve, the spot yield curve can be used to calculate the value of a bond. So, bond valuation using the yield curve means that calculating the current value, that is the price of a bond, by discounting what? Each future cash flow using the interest rate appropriate for its maturity. So the concept is you can have different cash flows occurring at different dates. So each cash flow should be discounted using the interest rate corresponding to that date on the yield curve. Not far-fetched from what we've done. So the spot yield curve can be used to calculate the value of a bond. That is the value of the bond using the curve present value. The curve present value. When we're talking about the value of the curve now, we're talking about the PV, the curve present value of each what? Of each coupon, of each interest. These coupon interests are payments. And when you determine your coupon, you discount this coupon based on what? The cost of borrowing associated with the bond. So talking about, okay, let me just put down a little note about that, because this is the time allocated for the class. After the class, I might not have time again to do that. It might take some days. So the spot yield, all right, let's just come this way. So bond valuation using yield curve, means that is calculating the current value. The current value simply means the price of a bond by discounting, that is by discounting each future. The formula Mr. Emmanuel put forth the other day, this is where I'm planning to use it. Discounting each future cash flow, that is using the interest rates, using the interest rates appropriate, using the interest rates appropriate for its maturity. So the spot yield rate now, the spot yield curve rather, spot yield curve can be used. When we're talking about the spot yield curve, we are talking about the R. So now the spot yield curve can be used to calculate the value of bond. The value of a bond. So the value of bond, using yield curve, is the present value. Please underline this in your note. Is the present value. So as you read, you have meaning to it. Is the present value of each coupon payment, discounted at the cost of borrowing, associated with the bond. So this can be calculated This can be calculated. This can be calculated using the formula below. Using the formula below. So now, what is the formula? Now, we said the spot yield curve is what? Is the present value, PV, of what? Of each coupon payment. The each coupon payment will be what? Coupon payment can be likened to what? Class. Coupon payment can be
Interest.
likened. Yes, interest. But is it an inflow or outflow?
Is an outflow.
Okay. Is in two ways. Is in two ways. To the
Exactly.
investor is an inflow.
Yes.
To the organization is an outflow. But with bond valuation, we are looking at it in the perspective of the investor. That is, the coupon is an inflow. So to calculate the spot yield, the yield curve, the formula is PV of cash flow. The cash flow is the coupon of year one. Let's make it in caps. Of year one. Divide by what? Divide by the discounting rate. That is the market discount rate or required rate of return. And that will be what? 1 plus what? 1 plus R. 1 plus R to the power of what? To the power of what? To the power of 1. Now, why is it not minus 1? Why is it not to the power of minus 1? Mathematicians, tell me. Why is it not to the power of minus 1?
So I think it's because you already the cash flow. You're already dividing it with the cash flow.
Yes, so it is assumed 1 is on top, so there is no need. Once 1 is on it, the minus will be eliminated. Yes, so if you leave it as 1 plus R to the power of minus 1, when you put 1 as the numerator, that minus will be eliminated. And that is why we have it in this way: 1 plus R to the power of what? 1 for the first year. So for year 2, you can have it as what?
Sir,
For
sorry,
year
please, I have a
2.
question. Sir,
Okay, I'm
so
with you,
if,
sir.
okay, if that numerator, which is the cash flow, assuming you do not put 1 in front, it will now be 1 plus R in bracket raised to power minus 1.
No,
If
sir.
there's no,
That is not the concept, sir. That one
okay,
is just telling you period 1. It's not
okay,
that one you are saying is just period 1. The cash flow being on it means that the minus 1 will not hold. You
okay.
understand? It's the cash flow that is that one. Let me put it as subscript. The one is
Yes, like
just
that's just
period.
for year one.
Yes, let's make it subscript. Period. You see? So
Okay.
for period 2, year 2, we're just trying to show the formula. For year 2, it will be what? It will be your cash flow in period 2. In period 2, divide by what? Open brackets. 1 plus what? 1 plus R to the power of what? The power of 2 for period 2. to the power of 2. Now, you can go on and on. When you have year 3, year 4, you can go on and on like that. But at the terminal point, at the maturity period, date, what will happen? You know, at the maturity date, you always have the redemption value and what? And the coupon. So what will happen in that case? It will be what? It will be your cash flow plus what? Plus the redemption value. Yes, or future value. Fine. So it will now be what? We'll have it as this. Your cash flow plus what? Future value, which can likely be the redemption, or the redemption value can be at par, at premium, depending on what the question is telling you. So as period N, because we don't know, this is just a format. This is just a guide. So it can be up to 10 years in that order. So divide by what? 1 plus R to the power of what? The power of N. To the power of N. So for you to get your present value or the price of the bond using what? Yield curve. Take note of the concept now. Using what? Yield curve. You know, you've been determining price of bond before now. But now, the subject matter is what? Yield curve. This is the formula. Define the formula where what? Where PV is what? PV is equal to what? Present value. Please take note of this definition so that you will not see the formula as something strange, or so present value or the price of the bond. The price of the bond. And your CF is what?
Cash flow.
Coupon. Your coupon, or what? The interest. The interest payments is a cash flow actually, but specifically it's coupon, interest payments in each period. In each period. And the CF plus future value. This
So
is
please, interest payment is interest payment to the investor, right?
yes, the investor is receiving it.
Okay.
So this is interest payments plus face value plus the face value of the bond at what? At maturity. At maturity. And the R is what? What is your R? Your
Discount.
R is market discount rate. Market discount rate, or can be termed as what? Required rates
Of return.
of what? Of return.
Return.
And what is your N? Your N is what? Number of years. Number of years. Number of years at what? At maturity. At maturity. Or we can also say, or redemption year. Redemption year. Now, when you're working based on spot, based on spot rate, you use this formula. When you are working based on spot rates, you use this formula. But where it is a forward rate, what will happen? Anybody to help? Sir Emmanuel,
Yes, sir.
when it
The
is a
formula
forward
will,
rate,
yeah, the formula will be cash flow for year one divided by open brackets 1 plus R, close brackets, open another brackets. That's for year one. Then for
very
year
good,
two, the cash flow for year two divided by open brackets 1 plus rate for year one,
very
close
good,
bracket, open another bracket, 1 plus rate for year two, then you close it. You will not scare it at all.
very good.
Like that, the number of maturity.
Yes. So, but why that? Let's ask ourselves, why that approach? Why do we have to go that way?
Yeah, I think forward rate is always used for hedging in case there is changes in the interest rates.
Okay. Now, yes, that is the formula, very correct. So the forward yield curve, this one we talked about is spot yield curve. Well, I said if you go to most of your literature, you might not have seen it explained. So the forward yield curve shows the interest rate that applies to borrowing or investing between two future dates. So the forward rate is derived from what? From spot rate. So for forward rate, you'll be giving different values, different discount values. Just similar to the example we looked at, we solved before now. You'll be giving different discount value. But the point is this: you accumulate the discount throughout all the years. You accumulate the discount throughout all the years. So one thing with the forward rate approach is that 1 year forward rate starts in year one. So what will happen? It means you will have to consider year one to year two when you are solving for year two. When you are solving for year three, you will consider year one, year two, and year three rates in that order, without squaring it, without raising it to the power of that particular year. So because of time, this is it. This is what we are expected to do. It's not something, it's very simple. So let me just copy this and adjust the formula. So that question on the platform, on the group, is on future yield curve. You see the forward rates there. So for this, you have the cash flow 1 plus R. So this is same thing, either you raise it to the power of 1 or not. It's still the same thing, same value you have. For year two, okay, let's write it. That is forward yield curve. Forward yield curve. So the formula will be this for year one. For period two, it will be 1 plus R. 1 plus R. Okay, what I will do is I will put the period 1 in front of the R. Let's make it for proper explanation. Let's make it superscript 1 plus R, period 1. For period 2, it will be period 1 discount value plus period 2. So you have it period 1. That is multiply now, not plus. You multiply period 1 multiply by what? 1 plus R in relation to that of what? Period 2. In relation to that of period 2. So you have it. If you have period 3 too, you do same thing. It will now be period 1, 2, and 3. So for this, we can now have it as what? Period 1 plus period 1 multiply by what? 1 plus R in relation to period 2, close your brackets, multiply by what? 1 plus R in relation to what? Period N. So this is when you have forward rates instead of raising it to the power, because you cannot have period 2 without period 1. That is the concept of forward yield curve. You cannot have period 3 without period 2. So you consider the discount value cumulatively in that order. So for you to solve that question on the group I posted, this is the concept we are to apply. Thank God for Mr. Friday. He forwarded those questions to me. I asked him to search for more. So he has forwarded about 5 or 6 questions, if I'm not mistaken. So which I'll also share with you in relation to this topic, all from the ICANN Pathfinder. So that question on the platform is from the ICANN Pathfinder 2025, not too far, so that you see the importance of this we are learning. So now, to solve a question in relation to the spot yield curve, let's look at an example. Let's look at an example. Example 1. Example 1. We have Patrick PLC. Patrick PLC wants to issue. Madam Chidima, are you in class? Want to issue a bond. It's not here. That is redeemable. That is redeemable in 4 years. Patrick PLC wants to issue a bond that is redeemable in 4 years for its par value. For its par value or face value of 100 naira, and wants to pay an annual coupon of 5% on the par value. The annual spot rates. Please follow the question. I'll call on one of us to explain what to do, because it's not far-fetched from what I've explained. The annual spot yield curve for a bond of this risk class is as follows. Now, let me quickly say something. That bond of the same risk class will have the same yield or rate of return. Please write it in your book and underline it or put it in a bracket. Write that thing in your book. Use red biro to cycle it. That this is a flashpoint. What am I saying? That it should be noted that bond of the same risk class, when you have bond who fall within the same risk, they will always have the same yield or rate of return. Please underline it very well. We are coming there. So the annual spot yield curve for a bond of this risk class is as follows. Is as follows. We have it. Let's have it in a table. Have it in a table. Let's say we have the year. We have the rates. For year, we have year 1, year 2, we have year 3, and we have year 4. The rates 3.5%, year 2 4.0%, year 3 4.7%, year 4 5.5%. 5.5%. 5.5%. So required and say required. Calculate the price. Calculate the price at which the bond should be issued. And okay, let's make this 1 and 2, the gross redemption yields. The gross redemption yields. So to solve this now, what are we going to do? Madam Ikechinyere, are you in class? Let me see those in this class. Madam Nkechi Nyere. Asana Ismail. Ajia Asana. Are you there?
Maybe they are cooking.
Okay. Oh, this I discovered that. Okay, don't let me say what I want to say. As if some of you are so cold at this level. Yes. At this level, you are so. Madam Odunayo. See, I'm not getting them. They are not picking my calls.
Hello, sir.
No, sir. We saw what is higher than PM.
I'm here, sir.
Are you telling me what to do based on requirement one?
We say in task that we'll be writing reports on taxation.
There's nothing bigger than PM here too. When you start seeing some scientific formulas. But now we are still coming. So, Madam Odunayo, can you tell us what to do based on the price at which the bond should be issued? Any idea?
I'm still looking at the question. Let me look at it very well. Let me see if I
Okay.
can.
All right, you know we don't have time. So, solution. Mr. AGK, are you there?
Ogami, sir, I'm here. I'm here. I'm looking at it as well.
Yeah, looking
I'm
at it.
he's looking at me, and I'm also looking at it at the same time.
Yeah, okay, please take a screenshot. I don't know if you've put it down as I was writing so that you understand what we are doing.
Okay,
So,
sir. I've not been consistent all this while. I have so much, but God will help us.
all right, so please let's read the question and see what they want us to do. The questions is saying that calculate the price at which the bond should be issued. From our explanation, when we are asked to calculate the price, what are we expected to do? To calculate the present what value, the PV. And for you to get the PV, this is what based on spot yield curve. So the formula will be what? The cash flow for what? Year one divided by what? The discount rate for year one to the power of one. For year two, the cash flow, it will be the same cash flow all through. And the cash flow is what? The coupon, the interest. So now, because of time, let's show our working. So calculating bond price, calculating bond price, that is using, you see, I'm emphasizing using because you can calculate bond price based on different ways. So this is specifically based on using what? Yield curve. So to calculate your bond price, you use this formula here. You use this formula, and the formula is what? We've defined this formula before. So your CF, based on the question, will be what? Your CF will be 5%. 5% of what?
5 naira.
It's 5 naira.
5 naira.
5 naira. Good. So you have to be up. So now, what will be your interest payment plus face value of the bond at maturity? That is this point here, CF plus FVN. It will be what?
105.
Okay, it will be 105. That is cash flow or coupon payment plus what? Plus the future value, that is redemption of face value. That is face value, which is equal to, let me define it again, coupon payment plus what? Plus redemption or what? Of face value. Of face value. Now, in relation to this question, your coupon is what? It's 5 naira. Your face value is what?
100 naira.
100 naira.
100.
Face value is 100. So the total at that point will be what? 105. 105. What will be your N? The N will be what? Your N is what?
4.
Your N is 4.
4 years.
Your
4
N,
years.
4
It's
years.
4.
So we have it as 4 years. 4 years. Now, what will be your R? The value of R for year one will be what? This is in percentage, right?
3.5.
In decimal, it will be 0.0335.
0.35.
In year two, it will be what? 0.040. I'm not mistaken. Yes, 0.040. And for year 3,
0.047.
it will
0.04.
0.7. And for year 4, it will be what?
So,
It will be 0.055. Now, this is the breakdown of all you need in this formula. So what are you going to do now? You impute them. Impute. You have it. So for year 1, your coupon payment is what? It's 5. What is your R? Your R is what? 0.035
0.035.
to the power of 1. For year 2, your coupon payment is still what?
5.
Still 5. And your R is what? 0.040
7.
to the power of what? 2. So for year 3, it will be what?
5.
For year 3,
105.
you have it
5.
as what? Still 5
Uh,
to the
1
brackets
0.047.
47 to the power of what? 3. And for the 4th year, it will be what?
105 over.
So we have it as 105 divided by what? Your R is what? 0.055
Yeah.
to the power of what?
4.
4. So when you do these mathematics, let's still go one step. Let's go one more step. So we have it as PV equal to what? Let me go one more step. It's saying that. So when you go one more step, 1 plus 0.035 will give you what? It give you 1.035. 1 plus 0.040 will give you what? 1.040 to the power of 2. This will give you what? And this will give you what? So when you simplify further, your PV will be what? Class, press your calculator so that when it is only you, you will not be scratching your head and be asking, how did they get this thing? You'll be telling yourself, this thing is wrong, even while it is not wrong. So press your calculator now. So it will be 1.035 to the power of 1. It will still be what? Anything to the power of 1 will remain same as that. Take notes. So now, when you divide 5 divided by what? 1.035 to give you what? 4.83 plus for the second year to be what? 1.040 to the power of what? 2. I have 1.0816. When I divide by 5, 5 divided by 1.0816, I have what? 4.62 approximately. For the third year, what is the value? Hope somebody is getting it. 1.047 to the power of 3 divided by 5. I should have 4.36 plus the fourth year, 1.055 to the power of 4 divided by 105 should have 84.7 what? Or 76. So your present value will now be what? The addition of all these. And when you add by your calculator, you should have what? 4.83 plus what? 4.62 plus 4.36 plus 84.76. I have 98.57. Somebody is raising up his or her hand. Yes, Madam Mary.
Good evening, sir.
Good evening, ma'am.
So I want to ask this 5. Why are we using 5 there? From the question, I did not say anything as 5. 5 divided by the rates under.
This is it, ma'am. Your
Okay,
coupon.
okay, the coupon.
Interest
Okay,
rate.
okay, I get it. Thank you, sir.
Yes, ma'am. Hope somebody is pressing his or her calculator and you're getting this. So the bond market price is what? What is the bond market price?
98.
Okay, fine. So the bond,
$98.57.
yes, it's 8.57. So the bond market price is what? Is 98.57. Any question, class? Madam Odoayo, is this one hard?
It's not hard, sir. It means the bond was issued at discount.
Very good. That is, now, there is something important about bond. And if you check the question I forwarded, there is a concept of this nature. So I want to ask, there's a relationship between interest and bond. What is that relationship? There is a relationship between interest and bond. What is the relationship? What is the relationship? The relationship is this.
Is the required return on the bond.
Okay. The relationship is this. Please take note. As you solve question, you observe this, I will say. The relationship between bond price and interest rate is inverse. It means when there is increase in interest rates, what will happen? The bond price will fall. When the interest rate falls, the bond price will do what? Will rise. Now, what is the meaning of this? Now, imagine that the market's interest rate increased to, let's say, 10%. And the market interest rate increased to, let's say, 10%. Now, new bonds, or we have the old interest rate to be, let's say, 7.5, and the market interest rate increased to 10%. You have an existing bond valuing at what? 7.5, giving an interest of what? 7.5. Now you have a new bond with an interest rate of 10%. What will happen? The new bonds are now offering 10% returns, while the existing bond is offering what? 7.5% return. What will happen as an investor? As an investor, will you want to go and invest in the old bond that is offering 7.5%? The answer is no. You want to invest in the new bond that is offering what? 10% interest. 10% interest. So if the interest rate increases, what will happen? The price of your existing bond will do what? Will fall.
It will fall.
The price of your existing bond, you have existing bond, that you are claiming you have bond, it will fall, so that you will attract more investors, new investors, because the new investors are looking at a better opportunity elsewhere. So the price of your existing bond must fall to make it attractive to investors. So you will always observe an inverse relationship between the price and the interest rate. So if interest rate rises, the bond price will fall. If interest rate falls, the bond price will rise. So now, looking at the B part of this question, that what? Calculate the price at which the bond should be issued, fine. The gross redemption yield. Now, to calculate your gross redemption yield, what are you going to do? Your gross redemption yield. The question is asking you to do what? The yield to maturity, isn't it? And when you are solving question on yield to maturity, what should come to your mind?
IRR.
Yes, the internal rate of return. So, calculating what? The gross redemption yield. The gross redemption yield. So, the gross redemption yield. The gross redemption yield. The gross redemption yield. The gross redemption yield can be calculated using what? Using yield to maturity. And yield to maturity is what? Your internal rate of return. Given what? Given the bond market. The bond market value. Because for you to get your IRR at year zero, you need something. The current market value. And the current market value, based on what you've just solved, is what? Given the bond market value, of what?
98.57.
98.57. As calculated in, let's say, in one above. So now, to solve for your IRR, you need to assume two discount factor. First, I will assume 5%. I like 5%. So I will assume 5%. So when I assume 5%, what will happen? When I assume 5%, somebody else can assume another value. So assume 5%. Assume 5%. And I'm assuming 5%. I have my year. I have details. I have what? I have my cash flow. And I have what? My discount factor. My discount factor will be what? My assumed 5%. And I have what? I'll have my present value. I have my present value. my present value. So now, how many years are we looking at?
Oh
We're
yes.
looking at 4 years. We're looking at 4 years. Now, since you are trying to calculate your gross redemption yield, year zero, your current value is what? Your current value is 98 point what? 57. 98.57. Now, at year zero, your discount value will be what? And the present value will be what? 1 multiplied by 98.50. You have it as what? 98.57. 1 multiplied by 98.57, you have it as 98.57. And also, now, do we have a constant annual interest payment? We have constant annual interest payment, and we have same discount factor that will be used for all. So we don't need to solve year after year. We can apply our annuity value. Please take note, in the question paper, your annuity table is there. You can also access it and see how you can get your annuity figure from it. I'll also show it in one of the classes. So now, since we have same value of interest, what are we going to do? Your annual interest payment or coupon is what?
5 naira, sir.
5 naira. Your discount value using annuity will be what? Everybody should know annuity by now. 1 minus open bracket 1 plus r to the power of minus n divided by r. You should know it by now. So when you apply 5% in your annuity formula, what will be the result? 3.546. 3.546. I hope everybody knows the annuity formula. You know, this is an advanced class. Some of these things you've studied them over time. The formula is 1 minus open bracket 1 plus r to the power of minus n divided by r. That is, for this, it will be 1 minus open bracket 1 plus 0.05 to the power of what? Minus 4 divided by what? Everything divided by what? 0.05. So when you do that, the answer will be what? 3.546. Please confirm. So
Yes, sir. Repeat.
3.546
Correct.
multiplied by 5, you have what? 17 point what?
7.3.
So this is your annual interest payments, present value for year 1 to 4. As at the 4th year also, you have your redemption value. Your redemption value is at the face value, is at par, and the value is what? 100. So for this 4th year, you apply your formula just solely for year 4, and that will be 1 plus r to the power of what? Minus n. So 1 plus 0.05 to the power of what? Minus 4. And that will give you what?
0.8223.
0.823 multiplied by 100. And this will give you what? 82 point what?
82.3.
This will give you 82.30. So what will be your MPV? Will this give us positive or negative MPV?
I think positive.
Of what value?
$1.46.
1.46. 1.46. So this is a positive NPV. We need to get a value that will give us a negative NPV. I'll also go and assume 10. I'll assume 10. Let's see. It's a try and error approach. It's not that every time these values will give us what we want. If it didn't give us, we'll have to determine it again. So now have it as what? Assume 10%. Assume 10%. So if I'm assuming 10%, this will be what? This will change. This will change. This will also change. And this will change likewise overall. So the discount factor, applying 10% in your annuity formula for 4 years, this will give you what?
3.17.
Hey, you're welcome.
Welcome.
3.17.
Multiply by 5. 15.85.
15.85.
Then, as at the 4th year only, 1 plus r to the power of minus 4, where your r is what? 10%.
0.683.
So multiply by 100, this will give you what?
68.3.
0.30. So your NPV will be what? Positive or negative?
Negative 14.7.
Negative 14.72.
72.
So with this, you can now apply your internal rate of return formula. And where is the formula? You can apply your internal rate of return formula to get your yield to maturity. Borrow this. So once you apply that, so you have it. To get your yield to maturity, A is what? Lower discount factor, and it is what? 5. The NPV of A, NPV of the lower discount factor is what? 1.46. Same value here as what? 1.46. And for NPV of B is what? Take note, originally this is minus. Your NPV of B is what? NPV of B 14 point what? 72. 14.72. So this is minus. Minus multiplied by minus. We change to what?
Plus.
So this will now be what? Plus. So the higher discount factor, 10, minus what? 5. What will be your answer? Take note, board mass. 1.46 plus 14. Is it 14? 14.72. What will that give to you? Let's press 1.46 plus 14.72. You have 16.18. Then 1.46 divided by 16.18 will give you what? 0.0902. Multiply by 10 minus 5, 5. Multiply by 5, I have 0.45 plus 5. I have what? 5.451. So your yield to maturity will be equal to what? 5.45%. Please, are we getting this? Are we getting
Yes, sir.
this?
Yes, sir.
Yes, sir.
All right. Okay, fine. All right, fine. So I have 34 minutes to the end of this class. So I have another question I wish to solve. Maybe I'll give that as an assignment to a very good question to test your understanding on this concept. I'll give that as an assignment. I want to talk about the bond duration. Bond duration. I want to touch everything that has to do with the question I forwarded on that group so that you go and solve it and forward my solution to me. So the bond duration. Bond duration. When we talk about this bond duration, we're talking about a concept that is similar to what we call the payback period. That is the fact that it will take you to get, it will take 5 years for you to get your interest, or for an investment to take place. The period of recouping back your money must not be that 5 years. It can be less than the period of the investment. So bond duration, what bond duration does is that it measures the sensitivity of a bond price to the changes in interest. And with bond duration, you have to see the weight, yes, the weight of the year in relation to the present value, in relation to the present value. So bond duration represents the weighted average time, the weighted average time it takes for an investor to receive the bond's cash flow. So with the weight, the weight is in relation to what? The present value of those. The weight is in relation to the present value of the cash flows. So the duration tells us how much a bond price is likely to change when market interests change. So as we've stated, that there is always an inverse relationship between interest rate and the bond price. So when we talk about the bond duration, we will look at the Macaulay duration and we will look at the modified duration. So the Macaulay duration, that is bond duration. Bond duration. The Macaulay duration. This Macaulay is the name of someone, right? Macaulay duration. So you know that the name is associated with the economists that have come up with this concept. So this Macaulay duration was developed by an economist named Frederick Macaulay. So the Macaulay duration is the weighted average time, the weighted average time that it will take all the bond cash flows to be paid. And this concept has to do with accounting for the present value of future bonds payments. The present value of future bonds payments. So the Macaulay duration helps an investor to evaluate and compare bonds independent. of their time to maturity. That is, this Macaulay duration, we can compute it in two ways. We have one simple formula, and we have the concept of using a table. I will use the table first before showing the formula so that you don't get scared. So for Macaulay duration, the concept is this. Very simple concept. Yes, let's use a table to explain the concept. There's also a formula to that, but the formula can look scary, but it's not. It's something you can hold. For the tabular approach, this is what we do for the table. You have the year, you have your cash flow, you have your discount factor. Now, your discount factor for duration will be your market yield, your market yield or return. So we have it. It will be given in the question. Discount factor at what? At a particular percent given, and you have your present value, your PV, and you have what? Your weight. Your weight. The question is this. To make it easy, I can term my year A, I can term my cash flow B, I can term my discount factor at a percentage C, and my PV. How do I get my PV? Somebody should tell me how to get PV.
It's B
What
times C.
Very good. So my PV, I will say it is D, and D will be equal to what? B multiplied by what? C. Now, how will I get my weight? My weight will be what? E equal to what? A multiplied by what?
A times D.
A multiplied by D. So once you know this concept, that is all about Macaulay duration. Once you can hold this concept, you should be able to solve a question on Macaulay duration. So since I've shown this concept, let's look at a question and see how well you understand. Before I will now show the main formula. Yes, then we'll use that formula to also solve the question and see if we arrive at same result. So, but I don't want to show the formula. If not, some people will go and sleep. So now, example, let's say an investor. Let's say an investor buys a 6% annual bond, a 6% annual payment bond, with what? With 3 years. With 3 years to maturity. The bond has a yield. The bond has a yield to maturity. Of what? Of 8%. And what? It is currently priced at what? At 94.85 per 100 of par. Let's put the English this way. Required. Calculates the bond Macaulay duration. Calculate the bond Macaulay duration. Now, based on what we've explained, I believe we should be able to solve this question. Solution. Now, Your coupon payment is what? Coupon payments.
6
That
naira.
interest for every year. Your cash flow to be 6 naira. That is 6% multiplied by what? 100. And this will give you what? 6 naira. Your current value is what? Current market value.
94 naira 85 kobo.
So 94 naira 85 kobo. What else? The number of years.
It's 3 years.
Number of years, 3 years. Please, this is how to solve SFM question. You'll be bringing it out one after the other. Even when the question looks so clumsy, bring out your variables out. It will give you understanding. But by the time you are reading it like newspaper, you are not even bringing out the points. You will ask yourself, who sent you? You understand? So when you bring it out in this order, we are still looking at little questions, but these little questions, when you go to the past question also, you see them pull them together as one question. So please learn to bring out the variables in this form. So as you do that, based on this table that we've shown here, what are you going to do? Let's copy this. What are you going to do? Now, based on this table, the table is our year. The A is for year. So how many years are we looking at? Year 1,
3
year
years.
2, and what? Year 3. Now, B are our cash flow. Your cash flow in this term relates to what? Your coupon payments, your interest. For year 1 is what? Is 6. For year 2 is 6. For year 3, it will be what? Plus your redemption value to be 106. Now, what will be your discount factor? I explained, not quite long. The discount factor will be what?
8%.
8%. That's the yield to maturity will be what? Your discount factor. 8%. 8%. Now, for year 1, discount factor for year 1 using 8%, 1 plus 0.08 to the power of minus 1 will give us what?
0.926.
For year 2, it will be what? 1 plus 0.08 to the power of minus 2.
0.857.
857. And for year 3, it will be what?
0.794.
794. So your PV is what? B multiplied by what? C. So when you multiply B by C, 6 multiplied by 0.926, you have what? You have 5.56. Then for year 2, it will be what? 6 multiplied by 0.857, you have what?
5.1.
5.14. Let's maintain 2 decimal points. And for this, it will be what?
84.16.
84.16. So what will be your weight at this point? Your total here is what? That is your total for PV is what? Total. And you add, this should be 94.86. So your weight, A multiplied by D. So the year 1 multiplied by 5.56 will give you what? Still 5.56. For year 2, 2 multiplied by 5.14 will give you what? 10.28.
10.28.
And for year 3, it will be what? 3 multiplied by what?
252.48.
84.48. Your total will give you what? The total will give us what?
268.32.
So you have it as 268.32. Where are we driving at? The number of years, the duration. So your Macaulay duration will be equal to what? The total weight divided by what? Total present value. Total weight divided by what? Total present value. So you have it as total weight divided by what? Total present value. Total present value. So based on what you've solved here, now your total weight is what?
268.32.
So 268.32. Your total present value is what?
94.86.
So what will now be the duration?
2.8.
2.23.
2 years.
2.33.
2.83.
So this is the period it will take for the investor to recoup back his investment, even before the expiry of the whole project, of the whole investment. Now, this is using the tabular approach. Using the tabular approach. It will not be good I don't show the formula. So I will
So
definitely
don't
show
show
the
us. Don't show us.
So I leave the formula.
Don't show us.
No, this class will not be complete. This is an SFM class.
I
It will
sure
not
know
be
that our
complete.
eye will turn.
No, it will not turn. Oh, how will it turn? So using the formula, Macaulay duration, I will say MD is equal to, let's show the formula. It's very important. It's not something that you cannot know. So it's something you can know. Is it not somebody that writes it there? So we have it this way. We have it, our formula will be, we have our coupon, that is C, multiplied by your period 1, that is T1, multiplied by period 1, let's use that as T1, divide by your rates, that is 1 plus your R to the power of what? To the power of 1 of period, to the power of 1 of period 1 plus period 2. It will be what? That's a repetition. And we have it as what? This will be, instead of T1, I have it as what? T2. That is a time period. Then I have this to the power of what? To the power of 2. To the power of 2 plus, I can come up, let me round it up. The last period, the redemption year, to now be your coupon plus what? Plus the redemption value plus what? Plus Tn, 1 plus R to the power of what? N, to the power of N. Everything here divide by what? Divide by what? I will say PO. And what is PO? PO will be your current market value, or I can say peanuts, your current market value. So this is the formula. So let's define your MD is equal to what? Your MD is the Macaulay duration that you want to ascertain. Your MD is a Macaulay duration. Macaulay duration. And your C is what? C is equal to what? Your coupon. Coupon is otherwise known as what? Your interest. Interest payments. Interest payments in each year. In each year. And what is your T? The T is what? The time period. The time period for what? For each coupon payment. For each coupon payment. What else? We have our C. Okay, that is we have this C multiplied by T. This, the definition can be coupon payments. Coupon payments multiplied by what? Multiplied by time period. Time period of the coupon. Time period of the coupon. And we have what? The C plus the face value. And this is what? The interest payments. This is your interest payments. This is your interest payments plus what? Plus your face value of the bond. To what? Of the bond at maturity. What else? We have our R. The R is what? Let me save my work. Oh, we have the R, that is maturity, or rather market discount rates. Market discount rates, or what? Required, take note of these words, required rate of return, required rate of return, or what? Or the yield. The yield. Also, we have N. The N is what? Number of what? Number of years. Number of years at maturity. Or what? Or redemption. Or redemption year. Or redemption year. Then the P naught is what? Is the current market value. Current market value. Current market value. Current market value. So now, using this question, can we solve? Using this question, can we solve? Yes, we can solve. Let's use this formula to replicate the result we have using the table. And these will be what? We have this formula. Your C is what? Your C is what? Your coupon.
It's 6 naira.
6.
The coupon
6. And your T, this is the period. This is what? 1.
is 1.
Now, your R under period 1 is what? Is 8%. So R is 8%. So it will be what? Plus 0.08. Isn't it? In period 2, it is what? Your C is what? It's still 6. Multiplied by what? The time. The time is what? 2. This is what? R 0.08 to the power of what? 2. The next period is 3 years. So this, your cash flow, this coupon is what? 6. Your face value is what? 100.
100.
And your T is what? 3.
3.
This T is multiplication, please. This is plus. Let me change it. This is plus. Why this is multiplication? This is plus. And this is multiplication. So now, these will be what? 0.08 to the power of what? To the power of 3. So class, simplify this with your calculator. Let's see. Then your PO, the P naught is what? The P naught 94.85. So these will give you what? When you solve, maybe I should go one more step. Let me go one more step and see. Let me go one more step. So now, these will now give me 1.08 to the power of 1. Remove that. 1.08 to the power of 2. For this, I should have 1.1664. When I raise it up, remove this. So for this, hope you are solving. Don't wait for my answer. So for this, it will be what? It will be 1.259712. We do this. This will give us numerator. This should be 6. This should be. I'm waiting for your answer, please. This should be 12. And this should be. I should have 318. And you go further, what will happen? And we go further, what will happen? 6 divided by 1.08. That will give you what?
5.555.
Okay. Let's do 2 decimal place. 5 points.
56.
So you have it as MD will be equal to you have it as 5.56 plus what? 12 divided by 1.664, 10.6. 7.9 plus 318 divided by 1.259712. We have 252.44. Divide by what?
So how did you get 318? Because I got 306.
That is 106 multiplied by 318. 6 plus 100, 106 times 3. So
Why are we not multiplying before we add for board mass?
no, this is how it is. Your redemption value plus your coupon. This is how it is. Your redemption value is what? It's 100 plus your coupon 106.
Okay, that's fine.
So we have it divided by what? 94 plus 94.85, and this will give you what?
2.83.
2.83. That is direct. Solving everything direct. 2.83 years. So you can see, what do we have when we solve for table? You can see same result. So you can see. So I know you like the formula approach more. So
I still prefer the table.
Yeah, I prefer the table, sir.
okay.
The table is easier.
Okay. So well, you've seen the formula now. That is not something that you cannot know. So there is another form, the modified duration. Modified duration. The modified duration is the Macaulay duration divided by what? 1 plus R. So for you to solve for modified duration, you must get your Macaulay duration first. Then when you get your Macaulay duration, you will now divide that Macaulay duration by what? By 1 plus R. So for modified duration is a measure. Modified duration is a measure of the percentage change in price of a bond. The percentage change in price of a bond. So in a question, you can be given old price and new price. Then once you get your new duration, once you get your modified duration, you can now compare with the old one, the percentage change. And your formula for percentage change is what? Your formula for percentage change is what? Old minus new divided by what? Old multiplied by 100. Old minus new divided by old multiplied by 100. So that when you see a question that requires you to compare the percentage change of the duration, you'll be able to do that. So modified duration is your Macaulay duration divided by what? 1 plus R. What is your question, please?
Hello, sir.
I'm with
I
you,
don't
ma'am.
know how 318. The
You said?
318. I don't know how you got the 318 used to divide the 1.259712.
This is it, ma'am. 6 plus 100 is what? Let me do this. 6 plus 100 is what?
106.
Multiply by 3.
Okay, 318. Okay, I was multiplying 100 by 3 first. Okay, sir. Thank you.
So we have it as modified duration modified duration. Modified duration is, I have gone through so many literatures about this. I discovered some literatures have some approach, but looking at what the ICANN study test puts, I've also adopted the ICANN study test concept, where I discovered some authors put this modified duration in different ways, but this is fine. I'm saying this for some of you that will go and consult other literatures and you see different things. Please, this is what the ICANN study test has adopted and some other literatures, even though some other books put it in a different way, but this is what you have to work with, please. So we have this as this would be modified duration. We have it as Macaulay. That is Macaulay duration. Macaulay duration divided by what? 1 plus R. And what is your R? It's only your R that you don't know. What is your R? Where R is what? Where R is what? Your gross redemption yield of what? Of the bond. Gross redemption yield of the bond. And when you're talking about gross redemption yield, it can be the gross interest rates. Gross interest rates of the bond. So this is how to derive modified duration. How to derive modified duration. Let's take these assignments. Let's take these assignments. I have about 2 assignments or 3. Or let's just go with 2. Let's go with 2 first, so that plus the one on that group, you go and solve it. For those of you that join late, you might not be able to solve it. You watch this video first before you can solve it. Before you can solve that question. May 2025, question 6. That is the question on the group. So I'll forward other ones, but let's take these assignments to buttress what we discussed in this class. That's an investor buys 3-year bond, with a 5% coupon rate paid annually. The bond with a yield to maturity, of 3% is purchased at a price of 105 per 100 of par value, assuming a 5 basis points, change, in yield to maturity. In yield to maturity. This 5 basis point change. 5 basis point is what?
0.05%.
So what will now be the application in relation to the yield to maturity you have? Or the yield value?
3.05.
Very good.
3.05.
3.05. And that will be your discount factor, the value you use for as discount factor. So required estimate modified duration. Estimate modified duration. This is assignment 1. Assignment 2. Sorry if I'm boring you with assignments. I don't want you to come back and write this paper again. I know some of you are doing the whole paper, some of you are writing, but as far as you're in my class, you have to solve assignments. I will close my eye, assuming it's my course you are only my course you are writing. So other tutors that you are attending their class too should give you assignments. So now, assignment 2. A government has three bonds in issue. As given below. That the government has 3 bonds in issue that all have a face value or par value of 100 naira and are redeemable in 1 year, 2 years, and 3 years, respectively. The bonds are of the same risk. I mentioned something about same risk the other time. Of the same risk class. I was thinking I'll be able to solve this question in class, but you go and solve it. Let me see what you can do. Since they are all government bonds, so it is also assumed, SFM is full of assumption, also assumed that coupons are payable on an annual basis. Now we have this scenario. Say bond A, which is redeemable in a year's time, has a coupon rate of what? Of 7%, and is trading at 103 naira. Bond B, which is which is redeemable, in 2 years, has a coupon rate of 6% and is trading at 102 naira. Bond C, which is redeemable, in 3 years, has what? Has a coupon rate of 5% and is trading at 98 naira. Required calculates the yield. Calculate the yield curve. For the 3 bonds. These are the assignment questions. You have 3 assignments. 1 is already on the group, plus these 2. So you have to solve them and submit to the group. For this assignment 2, you are asked to calculate the yield curve. What is that yield curve? Let's get the understanding. Can I get 1 or 2 reactions to this? What is that yield curve? What is the yield curve? I want you to have a clue of what you want to go and do. What is the yield curve? Yes. What is that yield curve? A response? Okay. When you look at the question, you have the current value of each bond. And this current value for bond A is what? Can I get a response? What is the PV of bond A? The PV of bond A, 103. PV of bond A is 103. Your coupon for bond A will be what? Your interest for bond A.
7 naira is the coupon, sir.
Very good, 7 naira. Your redemption value will be what?
100 naira.
100.
So at the maturity period, it will be 100 plus what? 7, which will be 107. For bond A, how many years are you looking at?
1 year.
1 year. Fine, 1 year. So let me just show one of the steps. Let me just show the answer to bond A. Let me solve it. To this SFM class, we can take more than the expected hours. Because I want you to get it. That is why I want to show it, so that you not just go and. So the yield curve yield curve for bond A will be equal to what? What will be your formula? Looking at all these variables we have, your formula will be what? Present value equal to what? Equal to your coupon plus what? Your redemption value. Divide by what? Divide by 1 plus what?
Tax rate.
To the power of n.
Yes.
To the power of n. Now, based on what you have, what you've analyzed, what is your PV? Your PV is what? 103.
103 for year 1.
Equal to what? You know, you are solving them independently.
Yes, sir.
Bond A is just year 1. So when you have it, bond A, your coupon is what? Your coupon is 7, and your redemption value is what? It's 100. Now, what is your R? Your N is what? 1. What is your R? Do you know R? Do you know the value of R? Do you know the value of R?
No, sir.
You don't know the value of
No, sir, we don't need the value of R.
your
7%.
yield.
Targets
40 investment property.
Your yield is what? Is your return. And that is what you don't know. So how will you get it? How will you get it? You do what we call what? You cross
We will
multiply.
cross multiply.
Cross multiplication.
Asset can be classified.
So when you cross multiply, what will happen? You have it as what? 103 multiplied by what? 1 plus what? R to the power of what? 1. Either you put 1 or not, it's already raised to the power of 1. So now, but let me put it to avoid, there is a concept I want to prove with this to the power of 1, so that when it is 2, you know what to do. So now, to the power of 1. So now, these will now be equal to what?
7 plus 100. 107.
So for you to make R stand alone, because you want to get R, what will you do? You divide both sides by what?
103.
By 103. Yes, divide both sides by 103. Please take note of this. Divide both sides by 103. So when you divide both sides by 103, because of time, I might not show it clearly. So it will now be what? 1 plus R equal to what? 107 divided by what? 103. And this will be what?
And now we have
This will be what? I need to close my class. Some people are already in another class, so that I will allow them. So plus 1 plus R. This will give you what? This will give you what? When you do 1 plus R.
339.
So let me just conclude my class. And so 107 divided by 103 will give you what?
1.
It should be 1.0388.
0.039.
So now, this is raised to the power of 1. This 1 plus r is raised to the power of 1. For you to remove that power, I want to explain this so that when you go to 2, you will know what to do. If it is, since it's raised to the power of 1, the principle of mathematics is this. For you have to have the square root or the root of 1. When you put the root of 1 on this, it will cancel this one. Then this other part too, we have the root of 1. Take note, so that when you have 2, you do the square root of this portion. The square root will cancel the 2, which is the power. Then you square this other part too to get the value of r. So since this is 1, this is also raised to the power of 1. 1 cancel 1, you have it as what? 1 plus r will be equal to 1.0388. So what will be the value of r? R will be equal to what? 1.0388 equal to, minus 1. So your R will now be equal to what? The R will be equal to what? 0.0388. So R will be equal to what? In percentage, 3.88%. Now, for bond B, take note, the question says they have the same risk, isn't it? So for bond B, in year 1, what will be your R? Your R will be this value, 3.88. But you don't know the R for year 2. So you will now solve for, you will have this. You will have this for your year 1. For your year 1. But take note, it will be 106. It will be 106. But the R here will be this value here. Then you will now do plus year 2. 106 divided by 1 plus r to the power of 2. But you don't know the r in year 2. So you now solve for r in year 2 in that order. In year 3, for the next bond too, you do same thing. You do same thing. Since they have the same risk value, you know the risk, the return for bond A. As at year 3, you would have known the return for bond B. Then as at year 3, you don't know the return for bond C. You will now solve for R in year 3. That is the concept in this question. Thank you very much. So see you on Saturday.